Hey guys, just thought to make a quick video on your recent today's AP. Okay, on chapter 4, 5, 6, 7. Alright, let's go straight into it. Alright, first question. Okay, which object is the largest inertia? Okay, so keyword here, inertia. Don't look at the rest, don't be distracted. Just go straight to the variable that affects inertia the most, which is mass. Look at the highest, 30D, answer. That's it. Okay, question number 2, moment of a force. What is it described as? Okay, I think the most common mistake if you were to get it wrong is the sum of anti-clockwise moments equals sum of clockwise moments, right? So this clockwise forces, this is actually moments, right? So this is actually a principle of moments, right? But anyway, this one is also wrong. It should be moments here. So moment of a force is simply just force times perpendicular distance, which is c. That's it. Okay, question 3. Okay, designer wishes to make a lamp more stable. So something to make it more stable, what are the two conditions? Mainly just increase the width of the base and lower the center of gravity. So if you increase the mass of the base, you actually lower the center of gravity, right? That's it. So answer A. Question 4, classroom ceiling fan, what is the energy change? It all starts with electrical energy to kinetic because you can see the fan is actually moving. Alright, and question number 5, okay, a student carries the following actions. Which scenario does he do the most work? So you must know what is work done. Work done is basically just force times distance moved. Okay, so the key is the distance must be moving in the same direction as the force. Okay, why it can't, the answer can't be A is because in A, if you have pile of books moving upwards, walking forward, these two are not parallel. They are perpendicular, so they are moving in opposite directions, right? So closing a drawer is the only one. You push a drawer in, it goes in the same direction as you're pushing, right? C and D can't be the answer because both of them, you hang from a monkey bar, you push a wall. None of the monkey bar or nor the wall, none of these move. So that's why distance 0, if you put it 0 here, F times 0, work done is 0. That's it. Okay, so that's it for the MCQ. Okay, section B, first question, define mass. Okay, you just need to define amount of substance in an object or body. SI units, kilogram. Okay, calculate the weight of the object on Earth. So W equals mg. Okay, so mass 60 g 10 newtons per kilogram. Just multiply that, you get 600 newtons. Okay, there's an error here, right? So one difference between mass and weight. Okay, it can be any of these. You can talk about mass being the definition of mass and definition of weight, one being amount of matter, the other one being a force, or one being scalar, the other one vector, okay, one being kilogram, the other one the SI units in newtons. Can have any of these. Okay, I'm sorry if it's a little bit blur here. Okay, but I think you will have those definitions. Okay, so well, next question, question 7. I've got the weight 0.06 Newton at a 20 cm mark as shown. This is the center of gravity. Okay, so state the principle of moments. You got to say sum of clockwise moment. Okay, this one you got to spell it out. Okay, equals the sum of anti-clockwise moments about the same pivot. Okay, so calculate the weight of the pebble. So you use, basically you're using the moments principle. Okay, so sum of clockwise moment is simply just 0.06. This is a meter rule. So you can see there are 10 spaces here. So each space represents 10 cm. So 0.06, this is clockwise moment, 0.06 times 30 equals to weight times 10, 20 here, right? So this is anti-clockwise, weight times 20. The rest is just math, so weight equals 0.09 newtons. That's it. Okay, part C, the pebble is replaced with one that's heavier. So if this is heavier, what does it cause? It causes a larger anti-clockwise moment. Can you see? Okay, so how do you answer that? Describe and explain one adjustment that can be made to the setup to obtain equilibrium again. So if I have a larger anti-clockwise moment, okay, you need to say I either move the pivot to the left or move the pebble to the right. Because if this is bigger, the larger moment, move the pebble, the pivot a bit more to the left. Why? Because you reduce the anti-clockwise moment so that it can balance out this clockwise moment. Another way is to move the pebble to the right. So either move pivot left or move pivot right. But both of them, the explanations will be slightly different. Okay, if you move the pivot to the left, you got to actually increase this the clockwise movement of the ruler weight to balance the anti-clockwise moment of the pebble. But if you move the pebble to the right, you actually decrease the anti-clockwise moment of the pebble to balance the clockwise moment of the ruler weight. Okay, question 8. That's pretty straightforward here. Okay, I think there's an error here. Okay, this one is just 2 times 40 mgh. So m is with 2 kilograms, they're given here. 2 kilogram, G is 10, 2 times 10 times H 40, so 2 times 10 times 40, that gives you 800 joules. Okay, part B, so no energy is lost. What's the kinetic energy just before it hits the ground? So this is a conservation of energy, so it needs to be 800 as well. Okay, so 800 joules, actual 100% conversion from gravitational potential energy to kinetic energy before hitting the ground, right? So how do you determine the speed of the plate? So using the conservation of energy, gain in KE when it reaches the ground equals to loss in GPE at the top. So half mv square, okay? So half mv square, this is a square here, okay? Equals to mgh. So you can see m cancels out, v equals to square root 2gh. And just substitute the rest, just maths 28.3 meters per second. Alright, so question 9 is pretty straightforward. Force, distance, first formula, work done. You gotta know what's force times distance. Both must move in the same direction, force and distance. So 200.5, that's 100 joules. And if you can fire 50 rounds per minute, okay, remember this 100 joules is for one round, so you must times 50 divided by the time. This is the formula for power. So power equals work done per unit time divided by 60. Okay, this will probably be the common mistake. Don't just divide by 1, you got to divide by SI unit of 60 seconds. All right, so answer 83.3 watts. Okay, next question here. Okay, you use this formula, density equals mass over volume. So you got density, you got volume. They ask you to calculate mass. So what is mass? So mass is simply density times volume. That's it. So alloy 1 or metal 1 here will be density times volume, 5 times 4 plus metal 2. Okay, 6 times 8. So these two answers add together will be 68 kilos. Okay, actually, technically, this is not alloy. This is metal and metal. Okay, got it? All right. Okay, so question part B. Okay, just draw the molecular structure of a solid, of a liquid. So you can see solid is all in neat patterns, but for liquids, still close together, but make sure it's not neat. Make sure it's not far also. It doesn't look like a, make sure it doesn't look like a liquid. Okay, I mean, it doesn't look like a gas. Okay. And the last part here, okay, just fill in the blanks for physical property for solid. You got fixed shape and volume. Liquids, no fixed shape but fixed volume. Intermolecular forces will be strong for liquid. Distance, very little space. This is little space. Okay, so you can see it's pretty similar. Strong, strong, little space over here. Okay. Last question, explain why liquids have a fixed volume but not a fixed shape. So 2 marks here. So first part to explain why it has fixed volume. Okay, fixed volume is because you have some strong intermolecular forces holding them together. So fixed volume is I cannot compress it. That's why it's incompressible because forces are so strong that's holding them. You cannot actually overcome those forces easily, right? Okay, but why does it not have a fixed shape? This is where the challenge comes in. Okay, no fixed shape. So think of something that has a fixed shape. The only state that has fixed shape will be solids, right? So solids having a fixed shape, but why solids have fixed shape? What's the main difference between solids and liquids? Okay, so solids have very strong forces, but liquids not as strong, right? So since forces are not as strong as a solid, so the liquids will take up the space of any container. Okay, the key here is you cannot say the forces are weak in liquids because if you say weak, you mean only the forces in the gas will be weak. All right, so hope you enjoyed this video. Doesn't matter, again, don't worry about your result, how you did it. Main thing, never give up. I'll see you soon.